Hello and welcome back. We have understood how Softmax regression classifier can do multi-class classification without doing multiple binary class classifiers, unlike the one versus all and one versus one. The Softmax regression classifier can do multi-class classification without doing multiple binary class classifiers. So we need to understand what is the cost function behind it, and what is cross entropy. The cross entropy is the cost function behind the Softmax regression classifier. Even for logistic regression, the cross entropy is the cost function. Right? If you try to put the k is equal to 2 here, you will get the same formula. Okay. So let us try to understand what is cross entropy and how it can actually measure the error and let the algorithm find out the best thetas. So entropy explains uncertainty or impurity. From information theory, entropy has got, the cross entropy has got a formula which actually explains the uncertainty and impurity in numerical form. Every statistic will give you, the statistical tool will give you a statistic which explains something, right? The entropy explains the uncertainty or the impurity in a quantified way. If the formula gives you a big number, that means uncertainty or the impurity is high. If the formula gives a small number, the uncertainty or impurity is low. So uncertainty or impurity can be understood as a number of best possible combinations to conclude. So if you take a small example, if you take a big room and 5 furniture items, you will have many possibilities to set it up. That means impurity is more. If you take small room and take the same 5 furniture items, you will have less possibilities because of space constraint. So that is less impure. Right? When you try to use this formula and try to calculate the unset entropy, on the small room you will get less and big room you will get more. And cross entropy is a formula quantifies the uncertainty. The more the uncertainty or impurity in the setup, the higher the entropy measure is. So let us take one example here and try to understand that. So suppose that there is a bag of coins with different colored coins. 4 red coins, 4 blue coins, 4 green coins and 4 orange coins, like this. And if you try to pick a coin out of that, the probability of getting any coin is going to be 4 by 16 because there are 16 items in there in total, and for getting blue there are 4 out of 16, right? 4 divided by 16. For getting red there are 4 coins and 4 divided by 16, right? Like that. For any category, for any colored coin to pick it up, the probability is 1 by 4. If you apply the cross entropy formula here, it is pi log 1 by pi. Sigma I is equal to 1 to n. There are 4. The n is 4 here, right? There are 4. The blue, red, green, and orange. P of blue log 1 by P of blue. P of red log 1 by P of red. P of green log 1 by P of green. P of orange log P of 1 by orange. What is probability of blue? 1 by 4. Red 1 by 4. Green 1 by 4. I substituted everything here. I took log base 2. So I have got 2 as the number. So the impurity is 2 here. You can say the impurity is 2 here. And the second setup, right? We have got 8 blue coins and 2 red, 2 orange and 4 green coins. Here the probability of getting blue is high. Out of 16, 8 are blue. So if you take the coin, take one coin, right? Most probably blue will come because most of them, half of them are blue, right? So the probability of getting blue is 50%, green is 25%, red and orange are 12.5%, right? So if you apply impurity, the cross entropy formula, you will get 1 by 75 because the certainty is more, uncertainty is less. More certainly you will get blue coin out of the bag because there are more blue coins in this. So the formula is actually giving you the uncertainty measure, right? Uncertainty is less when compared to this kind of a setup. Here the uncertainty is less. So cross entropy is the best fit, the last function for Softmax regression classifier. So that is cross entropy, and the same cross entropy we are going to use it in tree-based algorithms also. So thank you.